One of the really central ideas, or maybe cornerstone ideas of the Common Core in mathematics is these 8 standards for mathematical practices. These are things that people who do mathematics do. The first one, problem solving and persevering, is this is something that I think has been getting a lot of attention recently in fields, other educational disciplines known as grit.
So how many did she have to begin with? We don't know. So let's write that down to represent that.
This sort of intangible almost idea of being able to persevere in a problem or a task when the going gets rough, to stick with it. And it's not a character trait that folks have. We might say that some have it more than others, but it's really something that can be learned by persevering through difficult problems. If everything in the classroom takes 30 seconds or less to complete, there's no opportunity for students to develop that mindset.
I think we really need to remind parents that in the classroom environment, the teacher is making it a safe environment, and it's a safe place for students to struggle. That struggle isn't the same struggle as giving a child something that is developmentally inappropriate. We're giving a child something that we know they can tackle. We want them to try and communicate with a neighbor and collaborate with somebody and share ideas and talk through it, because as adults, that's what we do. We don't sit at our desk and bang our head and sit alone and are unable to solve something. We reach out to people for help. We talk about it. We try and then we try again. And if we want our children to exhibit those same kinds of behaviors, we really need to foster an environment where it's okay to do that.
One of the things that we know is if we want students to develop the kind of deep understanding you're talking about, that we do need to engage them in actually solving problems in class, not just standing up and telling. Or as one of my colleagues would say, teaching isn't telling, right? Told isn't taught. We really need students to experience the mathematics themselves, make sense of it, so that they're making the connections. And so the extent to which we can look at materials that both have a careful development of the content, but also engage kids in the kind of problems that'll help them build those mathematical habits of mind, along with understanding the content, will much better prepare them to be successful in the future.
A second practice is reasoning abstractly and quantitatively. When mathematicians solve problems, they easily move back and forth between the situation of the problem, the real life thing. How many gallons of gas is the United States going to consume in the next year? And then they find ways to be abstract about that, to model that in a way using mathematics. They're able to connect what they're doing mathematically to what the purpose of it is in the world.
One of the things that is emphasized in the Common Core standards is an idea of story problems that aren't traditional. And this is where I think it's really important for kids to kind of, what I say to my own kids at school is to make a movie in your mind. What's happening in this story? Can you explain to me what you're doing here? And then also take them back to the story so they're not just getting mixed up with the numbers. Make that picture in your mind and then try and translate it to an equation if you can.
Another practice standard in the Common Core is the practice standard about discourse. It is construct a viable argument and critique the reasoning of others. It's really being able to think about your own solution to a problem and be able to defend it to another person.
She thought about, I have to subtract the 12, so I'll have to subtract the 10 and then 2 more. But how's an easier way that I can represent it?
Very importantly, it's also about being able to listen to someone else's strategy, to make sense of it, and to agree or disagree.
That's a big focus for us. We talk about our math, we present our math, we even have a procedure in presenting. Students will present their work and then turn It's a set procedure that I've taught. Turn and say, do you have any questions or comments? Talk to your friends.
I think it would be less because 0 and 7 tenths is greater than 0 and 7
And that is for everyone else to actually learn from them. So that gives them this positive disposition towards mathematics, and they begin to enjoy it. They enjoy, talking about the ways that they are thinking about things. And the other students get to critique them, and the other students, and it's okay.
I respectfully disagree with Cliff because he didn't put the numbers by place value.
And it's perfectly fine that other students are critiquing them because they know that they will be critiqued as well.
I have them explain their problems to their peers so that their peers can also see that some of their other students in the classroom may not have solved it the same way that they did, but they got the same answer.
And what I see in kindergarten, in first grade, in second grade, in middle school, are teachers who are creating that safe space where students are collaborating with each other, where there's peer review of what you're doing, and so it's a safe space.
Well, it's important as a teacher for the children to explain themselves to me so I understand how I can help them where they're confused possibly. They're sometimes the best teacher for the other students in the classroom because the way they'll phrase something or put it out there, it helps children say, oh, that's a great idea, or that's not a good idea, and let me help her understand why that's not a good idea.
I feel like it's really, really important for us to help them to explain their thinking as often as possible, because this is where we draw on and find misconceptions or misunderstandings, and we're able to clarify those.
Modeling with mathematics, I think, goes back to the sort of practical uses. In what ways can situations in the real world be modeled and maybe more easily figured out or dealt with by treating them as mathematical problems and by representing them in ways using mathematics?
A lot of what you'll see in classrooms is kind of a reversal of what you saw in the past. A lot of times you saw just kind of the procedure being done repeatedly and then maybe a few real-world problems tacked on at the end, and maybe they weren't very authentic real-world problems. But now you'll see where teachers are really approaching the content from the real world to begin with. How does this look in the real world? There's real data that I can collect, and then we explore the math that unfolds from that real world problem. So there's really that understanding. I'm not just doing math to do math, but there's a purpose behind it. The students have been asking for years, why am I doing this? Why? Now we're starting with the why.
The way the Common Core talks about the use of appropriate tools is with the word strategically. And that's an important way to think about this, because you don't want technology being used to teach kids basic facts.
Well, the reality is calculators, computers, and all kinds of technology are out there. And students, just like adults, are going to use those for complex problems. What you don't want is students grabbing for a calculator to multiply something by 10. And so we want students to learn some computation, to know some facts, to know some procedures. And the truth is that developing mental math skills, that's the best tool we can give them in their toolbox. Precision matters. We want students to get the right answer. And everything we do is aimed toward giving students tools that will help them consistently get the answers to problems. The trick is there's a delicate balance between striving for precision and making students feel badly every time they make a mistake. And what we now know about learning and about intelligence is that it's from the mistakes that we really grow, and that's where the learning happens.
We don't want students to, leave the classroom thinking, oh, there are so many different answers. There's not one right answer. I don't know what the right answer is. No, we want them to be precise in their answer.
The last two standards for mathematical practice involve the use of structure and repeated reasoning. A good illustration of these practices is a pretty well-known story about a famous German mathematician named Carl Friedrich Gauss. So when Gauss was in primary school, his teacher gave students the problem of summing up the integers from 1 to 100. And He just wanted to keep them busy, I guess, for a while he had some grading to do or something. But to the surprise of his teachers and classmates, Gauss almost immediately wrote down the correct answer of 5,050 on his slate. And he explained how he realized that the first and last number, 1 and 100, add up to 101. But the second number and the second to last number, 2 and 99, also have a sum of 101. And so he realized that this sum just repeats itself 50 times all the way up to 50 plus 51, the last pair of numbers. So he just multiplied 101 by 50 to get the answer 5,050. With experiences and with an environment where kids can start to learn to make these connections, it's really something that all students can learn to do and to begin to see the world of quantities and numbers as mathematicians do by seeing structure and repeated reasoning.
The Common Core lays out a lot of these fundamental math practices, which are lifelong skills that are important for kids to have no matter where they go, if they major in the humanities, or art or music or chemistry. Those kinds of skills are really, really important and ones that I think again, that the Common Core gives us the opportunity to make sure our students that are graduating from our schools today have that opportunity to learn those skills.